Okay, example 6. It gives us the position function and asks us what the velocity would be when the acceleration is 0. I'm thinking we need to do a little bit of this by hand. All right, so we can take these derivatives. So I want to go ahead and do that. All right, so yeah, I do. So the first derivative, all right, is going to be, all right, -3, and then the derivative of sine is cosine. So it's going to be -3 cosine, copy, chain rule. And so the derivative of the inside part here is going to be 2 of those. So that'll be a half 0.5 t. All right. So if I clean that up a little bit, it's still not going to be great. I'll have negative 1.5 t, and then cosine 0.25 t squared. Now, here's the problem. Now, I could go from there, all right, but as far as using the graph, because if I have the velocity, I want to know when that slope is equal to 0. A graphing calculator will show that to me. It'll show me exactly when that is. But if we wanted to go again and then find the acceleration, well, we'd have to do product rule, okay, which isn't terrible. I think I'll do it both ways. All right, so the acceleration, S double prime. And I'm just going to type it in just like this here in a second. All right, it's going to be first negative 1.5 t, and the derivative of the second, which is going to be the derivative of cosine, is negative sine. So negative sine, copy. Chain rule, which is going to be, again, a 0.5 t. Okay, plus the second, which was the cosine. .25 t squared. And the derivative of the first, which is negative 1.5. There's some cleaning up there. I mean, like, obviously this is positive. I could factor out a little bit, I guess. I don't know. I think leaving it just like that's what I'm going to do. All right, now I want to show something. So if I do now, so that was position. This is velocity. All right, let me go ahead and write that out. This is velocity. This is acceleration. All right. So if I just go by the graphs, like as they are, and just type them both in, well, actually, I just did the acceleration one. So whenever I can find out when the acceleration one's equal to 0, find that moment, and then substitute that into the velocity equation. All right, which is right here. Okay. So I could do that. All right, and that's one way to do it. And then I want to show you another way too that you'll probably think is equally cool. All right. So let's go. Need some room here. Scoot that over just a little bit. All right, I'm typing this acceleration equation in. So I've got half of, I'll just type it in just like it is, just like it says. So I've got 1.5 x, and then times sine of 0.25 x squared, and times 0.5x plus the cosine of 0.25x squared. Okay, and then that was times negative 1.5. Okay, I want to graph that. Now, I've set my window to go from 0 to a little bit for like negative a half. Here, I'll just show you. Negative 1/2 to 4. So I knew it would go from 0 to pi. This whole thing is just from 0 to pi. And I want to know when that's equal to 0. So if I go back to the graph, there's only one place between 0 and pi. It's right here. So what I can do is I can say, calculator, please find that 0 for me. And let's go a little bit to the left of where we know it is. Hit enter. Go a little to the right of where we know it is. Hit enter again, and it'll find it. Now, here's the cool thing. X is currently going to be in my calculator this 1.6 blah, 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 blah. Now, there's two ways I could do this. All right, I could say, all right, I want to know what that value is when for the velocity. All right, so at that particular moment. So I could go out and I could say, all right, here's my velocity, negative 3 times the cosine of 0.25 x, because x is currently that stored value, squared. And then my little chain rule, don't forget it. So times 0.5 x. And this is going to be it. This is the velocity at that moment. So, all right. So the velocity of the object when the acceleration is 0 occurs when t equals 1.6 165. 165. Okay. Of the object, and is negative 1.92. Okay, now, but here's another thing I wanted to show you. All right, let's say, say we didn't take that second derivative. Say we just did the first derivative only, all right, which is negative 1.5 x cosine 0.25 x squared. Okay, and I wanted to know. All right, so this is the velocity equation. So if I look at the graph, there's the velocity equation. All right, if I wanted to know where is the acceleration equal to 0, well, that's going to be the bottom of this little hill. All right, the bottom of this little hill right here is when the acceleration is going to equal to 0, not velocity equal to 0. Acceleration is equal to 0 when on the velocity graph whenever it bottoms out, because the acceleration was negative and then it was positive. So at this moment, we have a moment where it had to be 0. So I could go second, calculate a minimum, because I could see it on the graph, and to the left of the hill, and then to the right of the hill. Okay, and find that value. And guess what? It's that 1.6, I mean, the whole thing, 1.6165. All right, so again, that's stored as x, which is really, really good. And so then I could, again, substitute it in, because I want to know what the velocity was, back up here again. All right, and so that original equation, the derivative is right there. And then I could find the velocity. Or let's just try this. Let's go math 8. All right, and x, and then what's this? Negative 3. I'm going to use the original equation. Sine 0.25 x squared. You know the plus 1 doesn't matter, but I'm going to go ahead and put it plus 1. And then I'm going to tell it to substitute in the x value that's currently stored in the calculator, which is right there, or on the last screen. All right, and there we are. Man, look at that. So, within rounding and stuff, I mean, that is a really good job. They're not different until right there. That's pretty darn good. Pretty darn good.